Hi guys, I thought I'd start today by looking at two examples. So we're going to look at example number 7, and this is to do with projectile motion. It says a particle is projected from a point O with a speed v meters per second and at an angle of elevation of theta, where tan theta equals 4/3. The point O is 42.5 centimeters, so 42.5 meters above a horizontal plane. The particle strikes the plane at point A 5 seconds after it is projected. Show that v equals 20 and find the distance between O and A. Right, always key to my plans whenever we do anything like this is to draw the diagram. So on the screen there you should see a diagram, and let's have a look at horizontal and vertical motion first. So I'm going to use s equals ut plus half a t squared. So I'm going to say that Sx, so the horizontal displacement, is equal to v cos theta t, and remember there's no acceleration in the horizontal direction, so that just stays like that. Sy is going to be equal to v sine theta t minus 4.9, so that's half a, so half g t squared. Now, some of the first clues that it gives us, it tells us that tan theta equals 4/3. I'm going to look at a little triangle here, a little right angle triangle. Tan theta is 4/3. Well, that's a 3, 4, 5 triangle. So that means that sine theta is equal to 4/5 and cos theta is equal to 3/5. Right, so that's got us in a nice position. So I'm going to now change here to say that Sx is equal to v times 3/5 t, and I'm going to say Sy is equal to v times 4/5 t minus 4.9 t squared. So we want to know what v is. Now, we know that t is 5 when it hits the floor from the question, and we also know that this has gone down by 42.5 meters. So minus 42.5 is equal to v times 4/5 times 5 minus 4.9 times 5 squared. So minus 42.5 is equal to 4v minus, what's 4.9 times 5 squared? 4.9 times 25 is equal to 122.5, and if I then add 122.5 to both sides, I get that 4v equals 80, so 1v must equal 20 meters per second. So, using the information that we were given, I could work through quite nicely that first part of the question, and I've used this equation here to help me solve that. The idea that it had gone down meant that this was negative, and here we had, the negative acceleration working in that direction. Right, that was part A. Part B says find the distance between O and A. So B, we're looking at SX to find the distance horizontally, to find what X is. You can see on the diagram. So SX equals V cos theta t. So equals 20 times 3/5 times 5, which equals 60 meters. So overall, we know that it's come 42.5 down and 60 across. So the distance from O to A, which on the diagram is this distance, is equal to the square root of 60 squared plus 42.5 squared, which equals square root of 60 squared plus 42.5 squared, 73.5 meters to 3 significant figures. Okay, and then I'm happy that that is the right answer. Good. Right, now I'd like to move a bit further on and we'll look at example 9. Which you can see up there now. It says a ball is struck by a racket at a point A, which is 2 meters above horizontal ground. Immediately after being struck, the ball has a velocity of 5I plus 4J, where I and J are unit vectors horizontally and vertically respectively. After being struck, the ball travels freely under gravity until it strikes the ground at the point B as shown in the diagram above. Find the greatest height above the ground reached by the ball. Now, the key to a greatest height question is that it has stopped moving vertically. So its vertical velocity equals 0. So in terms of equations that we are going to use, I think we might use Vx. I'm going to base everything on V equals U plus AT. So Vx equals Ux. No acceleration acting on it in that direction, so that stays the same. The velocity in the horizontal direction always stays the same. Vy is equal to Uy minus 9.8 t, because acceleration is minus 9.8. So we need the time when this equals 0. So I've got 0, and if I look for Uy, that's in the vector there, that is 8 minus 9.8 t. So 8 is equal to 9.8 t. So t is equal to 8 over 9.8. Divided by 9.8 is equal to 40 over 49 seconds, and I'm going to keep that as a fraction because I think that'll help me quite nicely. Now if I want to know the distance or the height that is, I'm going to use S equals UT plus half AT squared as my basis. So sy is equal to 8 times 40 over 49 minus 4.9 times 40 over 49 squared. So I have 8 plus 40 over 49, sorry, 8 times 40 over 49. Minus 4.9 times 40 squared over 49 squared. And that comes to 3.265 meters. Four significant figures. And so the greatest height we have to realise that it was projected 2 meters above the ground, so that's 2.2 plus the 2.65, because remember this is displacement from where it started, so we're having to add the 2, so that's 5.265 meters high. You know, you could have used v squared equals u squared plus 2as and you would have got that in one go, but there's more than one ways to do these sorts of things. Right, I need to find the speed of the ball as it reaches B. So, what we could do with finding is we need to find the vertical component of the speed when it reaches V. So I am going to use v squared equals u squared plus 2as for this one. So I've got vy squared equals uy squared plus 2 times minus 9.8, and its displacement when it hits the ground is -2. What was uy? Did we work that out? Well, that was 8, wasn't it? So vy squared equals 64 plus 4 times 9.8, 39.2. So vy squared is equal to 103.2. So vy equals 10.158. So if we were to think about what we now know, if I was to draw a triangle looking at the velocities, you can see that this velocity is 10.158 and this velocity is what it was at the beginning, so that is 5, because it was 5i plus 8j. Working out using Pythagoras, this squared plus that squared, so I'm going to do the square root 103.2 squared plus 25 squared . 103.2 is the squared, sorry. So it's 11.3 meters per second to 3 significant figures. And I'm also asked for the angle of velocity which would be here, equals inverse tan, arctan 10.158 over 5, which equals 63.8 degrees. Okay, so key things to realise is we're using our Suvat equations quite nicely, but we just have to consider the vector quantities going in the x direction and the y direction separately. So on this one here, I could use sx and sy. Here I was looking at vx and vy most of the time, although I did have to use sy for the greatest height. Key thing there, greatest height comes when the velocity is 0, and that's an important thing to realise.